Let's study the chapter logarithm. But before studying logarithm, let's introduce again or revise the concept of exponential number or exponential function. Let a be a positive real number. A is not equal to 1 and x be any real number. Then the number of the form a raised to x is called an exponential number. It is called what? Exponential number. So this base a, once chosen, it is fixed, and let x vary. So a raised to x is then called what? Exponential number, or if x is a variable, we can treat that as an exponential function. For example, if I say 2 raised to 3, it is an exponential number. If I write 5 raised to 7, it is an exponential number. But when I write 2 raised to x and x is any real number, then this 2 raised to x is called what? An exponential function. So this is the difference. Here 3 is the exponent or index or the power, and the base is 2. Here the base is 5. Here the base is again what? 2. Now in order to define this exponential number, the base has to be positive and base is not equal to 1. The fact is that if I choose a equal to 1, 1 raised to any real number is 1. So I am not getting anything other than 1. So that's why the restriction is kept on a, that it is not equal to what? 1. So this is what is an exponential number, or what is this is what? Exponential function. Now from this definition, we will try to define what is a logarithm. So a is a fixed positive real number not equal to 1. X is any real number. Suppose a raised to x is some y. So I can calculate what is a raised to x. Suppose a raised to x is what? Y. If a raised to x is y, the question is, to which power a should be raised in order to get the value y? The answer is x. This x is called logarithm. This x is called logarithm of the opposite side, that is y, to the base a, and we write this as x is equal to log y to the base a. This y is called the quantity and this a is called the base. Here a is base, here also a is base. This base a is written at the tail of this letter G, and this y is the quantity which is written exactly near what? This y. So we write x is equal to log y to the base a. So this is the base a which is written at the tail of this G, and y is written in front of what? G. So x means the power of a is called logarithm. So for example, suppose I write 2 raised to 3, we know the result is what? 8. So to which power 2 should be raised in order to get the answer is 8? That power is known as logarithm. So this 3 is nothing but log of opposite side, that is 8 to the base what? 2. So log 8 to the base 2 is 3, means to which number 2 should be raised in order to get the answer what? 8. So if we know the exponential, we can write the logarithmic form. One can go in the reverse direction also. So generally, you remember that when 2 raised to 3 is 8, then this power 3 is log of opposite side to the base 2. One more example let me take. Suppose if I write 3 raised to say 4, it is what? 81. So let us convert this into what? Logarithmic form. So power means 4 is equal to log of opposite side, that is 81 to the base what? 3. So log of 81 to the base 3 is 4 is obtained from the exponential form by writing power of 3 is equal to log of opposite side 81 to the base what? 3. Now I said that this is the exponential form and this is what? The logarithmic form. Moment you see log is there, it is a logarithmic form, and moment you see the power is there, you can say it is an exponential form. So one can switch from one form to other form whenever one form is given. So suppose we are given 3 is equal to log 8 to the base 2. Can we write this in exponential form? So forget about the logarithm. This 2 is taken on this side and this 3 is taken as the power of what? This 2. So this 2 raised to 3 is 8. Remove logarithm. 2 to the power 3 is 8. Here again you can see the same thing. X is log y to the base a. So I can write y equal to remove log a to the power x is y. Similarly over here 81 equal to 3 raised to 4. So suppose if I write z is equal to log t to the base b, then can we write this in exponential form? Answer is yes. B to the power z is equal to t. Conversely, if b raised to z is t, then this power z is equal to log of opposite side, that is log t to the base what? B. Base remains base in both exponential form and logarithmic form. Only where we have to write that, I am telling you, in logarithmic form, base should be written here at the tel of g, and in exponential form, as a base we know, we write there. So b raised to z is what? T. So this way one can define logarithm. Now let's go ahead and let's develop some rules of logarithm. So these are the two forms that we have seen. One is exponential form. From this I am getting what? The logarithmic form means x is equal to log y to the base a. Here very clearly, when I write x equal to log y to the base a, remember that a raised to x, because a is positive, x can be any real number and a is not equal to 1. Therefore, a raised to x is always positive. Any positive real number raised to any real number is a positive real number. For example, 2 raised to minus 3 is 1 by 8. Still it is positive. If I write half raised to 4, it is 1 by 16. Still it is positive. If I write 1 by 3 raised to minus 3, it is 3 raised to 3, which is 27, positive. So any positive base if I choose raised to any real number, then it is always positive, means exponential number is always positive. But this exponential number a raised to x is being called y. So y is positive, and because y is positive, so when I write x equal to log y to the base a, this makes sense provided this y is positive. So log of only positive number can exist. Log of positive number exists, and the base should be taken positive because the base itself is what? Positive, and a is not equal to what? 1. So when I write log of z to the base t, this will exist if z is positive, t is positive, and t is not equal to 1. These are the restrictions on the variables there in order to define log of z to the base t. So when I write log z to the base t, do remember that z is always positive, this quantity is always positive, and the base is not only positive, it is not also equal to what? 1. So these are the conditions. So when I say log of 0, it does not make any sense because 0 is not a positive number. If I say log of minus 5, this does not exist because minus 5 is not a real number. If I write log of 5 to the base 1, this is against the rule because base cannot be equal to 1. If I write log of 10 to the base minus 2, again this does not exist because minus 2 is not a positive number. So whenever all these conditions are satisfied, log z to the base t makes sense. Otherwise it won't exist. So this is about the logarithm. Now we will discuss rules of logarithms in the next part.